Okay, we have 2 more sections of this chapter.
Woo!
Okay, this section 4.6 and then 4.7, and then we're done. 4.7 we'll do Monday. 4.8 we'll probably work on the review in class. Or on Tuesday we'll work on the review. Wednesday we'll go through the review. Thursday will be the test. Chapter 4.
Up next week.
Yes. Okay. When we learned Cramer's rule, one of the things we needed to know was how to do a determinant, because determinants are used in Cramer's rule. Okay. So in order to solve systems of equations using the inverse, which is the last method we're going to learn, which is my favorite, because to me it's easiest with a calculator, we have to know how to do a determinant, and we also have to know how to find an inverse of a function. Okay. So today we learned about how to find the inverse, and then Monday we learn how to apply that to actually solve systems. Yes.
Can I get the review on Monday?
Yes.
So we'll be on Wednesday, so we can do it.
Yes. No. Okay. So first off, when you multiply any number by its inverse, what do you get? What's 3 times 1/3?
3, 1.
Is it 3 or 1?
It's 1.
Okay. All right, 1. This is called the multiplicative inverse, right?
Wouldn't the inverse be negative?
No. That's the opposite inverse. Yep. So this is the inverse. So when you multiply a matrix by its inverse, you get the identity matrix, because 1's the identity property, right? When you multiply something by 1. So you get the identity matrix. Okay, but you don't just write a matrix with one number. So the first thing you need to understand is the identity matrix on a 2 by 2 is this. If I multiply any matrix by this matrix, any 2 by 2, I will get the exact same matrix. Okay, let's try it. Okay, how do I multiply?
Inverse. So 1 times.
I take this row by this column, right? 1 times 3 plus 0 times negative 2 is just 3, right?
Right.
1 times 4
4.
plus 0 times 0. 0 times 3,
0.
1 times negative 2. 0 times 4, and 0 times 0. When I multiply any matrix by the identity matrix, I get exactly what I started with. Okay? On a 3 by 3 or 4 by 4 or 5 by 5, what you'll notice is the 1's just make a diagonal. Okay? So if I went 4 by 4, I could add a 0, 0, 0, and then it would be 0, 0, 0, 1. Right? 1's just make a diagonal. That's the identity matrix. Okay? So there may be questions where you're given 2 matrices and they want to know if they're inverses of each other. So all you have to do is multiply those 2 matrices together. If you get the identity matrix, 0, 1, 1, 0, or 1, 0, 0, 1, right? They are inverses of each other. Just like if I wanted to know if these 2 numbers were inverses of each other, I'd multiply them by each other and get 1. If I got 1, I knew they were inverses. Okay? If I have 2 matrices and I multiply them together, I get the identity matrix. Those 2 matrices are inverses of each other. With me so far? Yes. Yeah, that's right. Okay. Oh, okay. All right. Thank you. Yep. Thanks. Bye. Okay. So now, to find the inverse of a matrix, if I wanted to know what I needed to multiply this by to get the identity matrix, that would be the inverse of this matrix, right? Okay. So to find the inverse of this matrix, what you do is you switch these 2, and then you just keep these the same, but you change the sign. Okay? Then you divide it by the determinant. Okay, and what's the determinant here? It's 0 minus negative 8, which is positive 8. Okay, and so really this is the same as taking 1/8 times this matrix. Right? 1/8 times 0 is 0. 1/8 times negative 4 is negative 1/2. 1/8 times 2 is 1/4. And 1/8 times 3 is 3/8. Okay, so let me go through that one more time. You switch these two terms. You leave these two the same but change their sign. And you divide by the determinant of this matrix. And the determinant of this matrix is 3 times 0, which is 0, minus negative 2 times 4. 0 minus negative 8 is positive 8. And when I divide by 8, it's the same as multiplying by a fraction.
So we don't need to do those two up there, the top two?
Here?
Yeah.
Not for what I'm explaining right now. The point, though, is this matrix times its inverse gives me the identity matrix. So let's check it. 3, 4, negative 2, 0. 0, negative 1/2, 1/4, 3/8. Okay, we're going to check it and see if I did the identity right, or the identity matrix, the inverse matrix, correct. Okay, 3 times 0, 4 times 1/4. 3 times negative 1/2. So it's negative 3/2. 4 times 3/8.
6.
What's 12 over 8 simplified? 4 goes into 12 3 times. 4 goes into 8 2 times 3/2. Negative 3/2 plus 3/2? With me? Negative 2 times 0? 0 times 0? Negative 2 times negative 1/2? 1. 0 times 3/8? 0. 1 plus 0? Sure enough, I multiply those together, I got the identity matrix. Okay? So you need to know when you multiply any matrix by its identity matrix, by the identity matrix, you get the same matrix. If you multiply a matrix by its inverse, you get the identity matrix. To find the inverse of a matrix, again, switch these two. Change the sign on these two. Leave them the same. Find the determinant of this matrix. Multiply this matrix by 1 over the determinant. That's the inverse matrix. And we know it's the inverse matrix because if we multiply this matrix by the original one, we get the identity matrix.
That's a lot of words.
Okay? Let's look at the textbook check now that you know this. To find the inverse of a matrix, of this one below, you first need to find the determinant. Next, you multiply 1 over the determinant by a new matrix. What is the first element in the first row, first column of the new matrix? D, because we switch A and D. Continuation from 1. What is the element in the second row, first column?
Negative B.
Negative C. You don't switch those. You just make them both negative. Question 3. If the determinant is 0, the matrix is called, this was in the reading, singular. If the matrix is singular, you can't find the inverse. Question 4. To prove a matrix is the inverse of another matrix, you would multiply the two matrices together and show the resulting matrix is the identity matrix. The matrix below is called the identity matrix. Okay? So we are not going to work on finding the inverse of a 3 by 3. All you need to know is how to find the inverse of a 2 by 2. I will show you on Monday how to find the inverses on a calculator of any size. And Monday then we will learn how to use this knowledge and a calculator to find the solutions of systems of equations using the inverse of matrices.
So when we take the test on Thursday, are we going to be able to use this part as a calculator?
Yes. I will probably, you'll have to know how to find the inverse of a 2 by 2
Oh, okay.
manually. But other than that, you'll be able to use a calculator.
Can I borrow this pencil?
Yes.
Can I borrow this?
Yes.
Oh boy.